4.2 continue. Okay, if we are going to graph functions, okay, we have to have a base that we can graph with, okay? So if we want to graph f of x, let's graph two different ones. F of x equals 2 to the x power, and I want to graph g of x equals log base 2 of x. Okay. To graph this one, it's very simple. I plug numbers into x, I get outputs, I graph it. Okay. I'm going to do negatives and positives into that, and it shouldn't be that hard to figure out or do. So if I plug in -2, -1, 0, 1, and 2, I'm just going to write what my outputs are. So 2 to the -2 should give you 1/4. Okay. 2 to the -1 should give you a half. Anything to the 0 power is 1. 2 to the first power is 2, and 2 squared is 4. Okay, so I just make a chart, and then from there I'm going to graph. So if I go to graph this, I would have -2 and a 4th. I would have -1 and a half. I would have 0, 1, 2, 1, 2, and 2, 4. So my graph looks like this. Okay, my exponential function. If I want to graph log base 2 of x, okay, log base 2 of x is the inverse function of f of x equals 2 of x, because if I rearrange this, I say 2 y, right, equals x. Is that how I write it? Yeah. Yeah. I would say 2 of y equals x. Okay? So in this, it's the inverse function, which means I'm plugging numbers into y and getting x's out. Okay? So if I plug things in on this chart, okay, I'm going to have y here so that I don't forget. I'm going to plug in -2, -1, 0, 1, and 2. So when I plug -2 into this, I'm going to get a 4th for x, right? When I plug in -1, I'm going to get a half. When I plug in 0, I'm going to get 1 still. When I plug in 1, 2, and 2, 4. But it's an inverse function. Okay? So what happens is this. When I plug in -1, because I plugged in, or -2, because I plugged in my y, I get a 4th. When I plug in -1, I get a half. So we're graphing this one opposite of how we graph this function. When I plug in 0, I get 1. When I plug in 1, I get 2. And when I plug in 2, I get 4. So this function curves like this. And this is its line of symmetry.
Where did you
Okay.
get the line of symmetry from?
The line of symmetry just goes in between them because it's like, because it shows that it's inverse. So if you have something in logarithmic function, okay, you have to do what we did yesterday. You take the base, you raise it to what it's equal to. Remember, this can always be replaced by y, whatever's here. So 2 to the y equals whatever this is, and in this case it's x. So when I have a logarithmic function that does not have a base of 10, I can't put it in my calculator. I have to change it to this first, input numbers for y, and I'm getting x's out. And I've got to graph backwards to what I'm used to doing. Okay? I'm graphing y, and then x, y, and then x. Okay? If it's in this form right here, I just plug numbers into x, and I get values out for y, and I plug what I normally do. If I have a base of 10, okay, and let's say I have something that says log base 10 of x, and they want us to graph f of x equals log base 10 of x. If it has a base 10 of x, that's the button that says log on your calculator. Okay? So once again, I would take -2, -1, 0, 1, and 2, and I'm just going to plug those numbers into x. Okay? So I'm going to say log -2 and press enter. If I press log -2, okay, I have a problem. It says domain error. Okay? Here's the reason why. When I have a base of 10, I'm not going to have negatives in there. Okay? So you might want to do some fractions here instead. We'll try 0 and see if it works. We're going to try 1/4 and 1/2. Okay? So if I say log of 0, I also get a domain error. So what's going to happen is it's not going to cross over that y-axis. So let's do 1/8. So log base 10 of 1/8, you have to use parentheses and do 1 divided by 8, and you should get -0.90. If I press log of 1/4, I'm going to get -0.60. If I press log of 1/2, I'm going to get -0.30. Log of 1 is going to give me 0. And log of 2 is going to give me 0.30. So I would graph that. Go 1/8 and I'm at -0.90. Go at 1/4 and I'm at -0.60. 1/2 -0.30. 1 is 0 and 2 is 0.30. So I have a graph that's going slowly up like this. But it's not going to cross this line here. Okay, so I can put in some things that way. And then, of course, I would have a vertical asymptote of my y-axis. Because it's not going to cross into here because that's when the domain error occurs. So that's how you can figure out what your vertical axis or your vertical asymptote is. Okay. Then there are a couple other things with graphing functions, such as, and we're going to end with logarithmic functions, and tomorrow we'll talk about natural log functions in this section still. Remember when there are things on the outside of my function or things on the inside of my function, it shifts what happens. So if I have a function that says g of x equals log base 10 x minus 1, okay, that means that my graph can be attained by shifting the graph that I just created, okay, and I'm going to shift it to the right 1 unit. When this is with the x, it shifts it to the right or left. Okay? So if it's in with the x, it's going to shift it to the right or left. It's going to do opposite of what you think. So if you think if it's a negative, that means it's shifting it to the right 1 unit. So the only thing I added to this graph right here is that -1, which would take each of these points and it would shift them 1 whole unit to the right. So instead of this being 1/8, it's going to be 1 1/8. And instead of 1/4, it's going to be here, and that shifts to there, and this one will shift to here. So my graph simply shifts, and my domain changes to 1, because it's not going to cross over 1. So my vertical asymptote becomes x is greater than 1. That tells me my asymptote. So I have some shifting happening there. If you have one where it has addition on the outsides, such as h of x equals, actually I want to say 2 plus log base 10 of x, okay? So if I have something like that, with the 2 added to the outside, okay, this tells me if I'm shifting up or down. So this tells me right here if you're shifting up or down. Okay. In this case, I'm shifting 2 units up. Okay, so from this original graph here, I'm going to shift this 2 units up. So 1, 2. This is right there. So it will be 1, 2, 1, 2, and so this graph shifts like this. Okay, the vertical asymptote stays the same. It's not going to cross over the y-axis. So those are what tell what's happening in my graph, what shifts are going on. And that's what we're going to work on today. And then tomorrow we're going to move into natural log, and we'll do graphing with that and calculator work with that.